Welcome all of you to SST College of Arts and Commerce. This is SST Edupedia. Myself Krishna Salgaonkar. I am an assistant professor from Department of Science. Today we are going to discuss course Principle of Geographic Information System, which is a part of TYIT semester 6. The topic which I choose for this presentation is spatial referencing. So let's start with the topic. First, we will try to understand what is meant by spatial referencing. Spatial referencing refers to the process of identifying the location of an object or feature in physical space by relating it to a specific reference surface. So, you have to identify the location of an object or a feature by referencing it to the specific reference surface. This can be done using a variety of reference surfaces such as geographic coordinate system, or projected coordinate system, or a local coordinate system. Now let's try to understand what is the geographic coordinate system. A geographic coordinate system is a reference surface that uses latitude and longitude to specify the location of a point on the Earth's surface. You might have been learned this thing in geography at school time, that we are using longitude and latitude to specify the locations of the objects. So that is our geographic coordinate system. The most commonly used geographic coordinate system is WGS 848 for World Geographic System 1984. Then projected coordinate system. System is a we have seen the geographic coordinate system. Now we are moving towards projected coordinate system. Actually, the surface of the Earth divided is onto two-dimensional flat surface. We have to imagine it as onto a two-dimensional flat surface. This follows for accurate distance and area measurement, but distorts the shape, angle and scale of the feature. These are mainly different types of map projections, each with its own set of advantages and disadvantages. So as shown in the diagram, the Earth's surface is projected in a different way. So you can see in the diagram, each one of is having its own advantages as well as disadvantages. So first one is a geographic coordinate system, second one is projected coordinate system. Why we are using it to locate the locations on the Earth's surface. Then coordinate transformations. Once this thing is done, we have to understand what is coordinate transformation. Coordinate transformations are used to convert coordinates from one reference surface to another. This is often necessary when working and with multiple data sets that use different coordinate system. See, suppose I have a geographical coordinate system and I have to convert it to the projected projected coordinate system. So geographical to projected, that is called as coordinate transformation. The most common coordinate transformation is between a projected coordinate system and a geographic coordinate system. It can be done using software tools that use mathematical algorithms to perform the convergence. It is important to note that while the coordinates may change when a transformation is done, the location of the feature remains the same. So even you do the transformation, the location of the feature is not going to change, it will remain the same. Spatial referencing and coordinate system are fundamental concept in GIS, mapping and surveying, as they allow to link real world features to their digital representation. So basically, what is a spatial referencing? Actually, we have to find out the location of any object or place on the Earth's surface. So for that, we are using geographic coordinate system or projected coordinate system, and we have to understand the coordinate transformations also, that we have to convert the geographic into projected one. So that is the first part of the presentation. Then there is satellite based positioning also we have to understand, because this is also very useful in spatial referencing. Satellite based positioning is a method of determining the location of an object or feature on or near the Earth's surface by measuring the time it takes from a signal to travel from a satellite to a receiver on the ground. This method is useful in many applications including GPS, Global Positioning System, GLONASS, that is Global Navigation Satellite System, and Galileo, that is Global Navigation Satellite System. So basically what is the satellite based positioning is a method to determine the location of objects or features which are there near to the Earth's surface, and this is measured with the help of the signal. The signals are sent to that object, and when they traverse back, that time is calculated. Based on that calculation, the distance is decided. So this is satellite based positioning. Then there is one more term which we should know, that is absolute positioning. Absolute positioning is a method of determining the exact location of an object or feature or on or near the Earth's surface. This is typically done using GPS, where the receiver on the ground calculates its position by measuring the distance to at least 4 satellites in the GPS constellation. The location is then determined using trilateration, which involve solving a system of 4 equations with 4 unknowns. So basically we have to decide the exact location of an object or anything which may be near to the Earth's surface or on the Earth's surface. So that is called as a absolute positioning. Obviously, whenever you do such type of calculations, they are not accurate. There are some errors in calculating all these positions. Errors in absolute positioning can occur for a variety of reasons, including signal interference, atmospheric effect, and receiver errors. These errors can be mitigated by using different GPS, DGPS, which involve using a reference receiver located at a known points to collect for error in the signals. So we can have some receiver at different locations, and we can calculate the values from different location, and then we can decide actually the error can be minimized, but there will be some error always. So what's our aim, that when we calculate the absolute position, we have to minimize the error, and we should go to the accurate values. So that's what achieved by keeping receivers at different locations. Relative positioning. Relative positioning is a method of determining the relative location of an object or feature with respect to a known reference point. So with respect to the known reference point, you have to decide the locations. This is typically done using network positioning, where a network or a receiver is used to determine the relative positioning of a mobile receiver. Then we will try to understand what is a network positioning. Network positioning is a method of determining the position of an object or feature by measuring the relative distance to a network or reference station. It is commonly used in RTK, real-time kinematic, GPS, which use a fixed reference station to correct for errors in the signal, allowing for sub-centimeter accurately. So network positioning is a method of determining the position of an object or feature by measuring the relative distance to a network or reference station, and it is commonly used in RTK, real-time kinematics. So In this presentation, we actually started with referencing. We try to understand what is spatial referencing, and then we come to the second point, that is satellite based positioning. So under satellite based positioning, we say the absolute positioning, errors in absolute positioning, and relative positioning. So that's all about spatial referencing and network positioning. Hope you understand the topic well. Thank you, everyone.